when you look at sort of the regulatory requirements about data retention and data privacy and data protection for that data, as it traverses those boundaries, the regulations change. And where you're being governed can change. And so you want to take into account what data can move and what data can't, and apply policies and controls to that infrastructure that's rooted in hardware to be able to enforce those requirements to make sure that you aren't violating various compliance regimes and compliance requirements for protecting the data as it transitions across the cloud.
This is a Security Weekly production. Security Weekly is a resource of Cyber Risk Alliance.
The Cybersecurity Collaborative, in conjunction with Cyber Reason, is proud to present CISO Stories. Each week, CISO Stories takes a deep dive on security leadership. The Cybersecurity Collaborative is a unique membership community enabling cybersecurity leaders to work together in a trusted environment. To learn more, visit securityweekly.com/CSC. I'm your host, Todd Fitzgerald, and this week we welcome Steve Orrin, Federal CTO at Intel.
Well, Todd, it's a pleasure to be here as well. And it goes back to the early days in the mid-90s when the technology around security and the security field itself was really in its infancy. I found it as a fascinating area. And for me, it's always about the solving hard problems, the challenges of being able to protect information against active threat, innovating new approaches and thinking outside the box. That's always been the thing that sort of drives me and gets me up in the morning. And when I first started information security and in the security domain back in the mid-90s, there was the threats were just starting to be understood. So the opportunity to come in and try to solve those problems up and down the stack really offered the chance to go off and do something interesting. And it's not been boring ever since, and it's kept me well engaged, both in the startup world and now for the past 16 years at Intel Corporation.
Well, that's great. I mean, I can clearly understand. I mean, seeing many different challenges. I mean, with security today, we haven't had a lack of challenges, have we?
No, it's like every couple of days we read there's yet another data breach, ransomware attack, supply chain attack. The threats have become much more prevalent and are actually making it into the standard press. So we really understand that we're under attack. Although many of us in the security field have known this for many years, it's sort of crossed the chasm into the popular culture. At the same time, the complexity of the systems we're trying to protect is making it harder and harder to keep up and to deploy the right security policies and the right security controls. So it's an ever challenging sort of cat and mouse game that we're all working on, trying to make sure that our systems and our data maintain their security in the state of active threat and active attack.
So, Steve, speaking to that complexity, you wrote a great piece for the CISO Compass book called Why Hardware Matters in Moving Securely to the Cloud. Can you walk us through that piece?
Absolutely. And it really comes to the core of why you have to think about the full infrastructure. Because a lot of times when you think about moving to cloud, it's, I want to go into have somebody else manage my infrastructure, somebody else manage the complexity behind the scenes so that I can just get to my business, which is running my applications, processing my data, moving my data around. Recognize that there are security concerns that don't disappear when you move data into the cloud. So when you take a look at moving to the cloud and putting our data into the cloud and our applications, the infrastructure does matter because it's more than just having somebody host the complexity behind the scenes. It's understanding that as your data is moving, the workloads are moving, and the co-tenancy of the cloud environment, your security requirements, the regulations upon which you're being beholden to, don't change. And so you need to be able to figure out, how do I enforce those security controls and policies on my data and on my workloads and applications, no matter where they run. As we've seen, the cloud by itself doesn't give you better security. It gives you the ability to manage things at scale, but you have to do that with security in mind. Now, where hardware comes into play is it allows you to extend your policies that you would do internally out into the cloud, and it gives you capabilities that are sacrosanct within the system. You're not just relying on the software security controls or the operational controls. You can route those controls directly into the hardware itself, into those immutable capabilities that are driving that infrastructure. So when you start thinking about why it's important to take advantage of security that's inherent in the hardware platforms when moving to the cloud architecture, it's because there are differences in the security postures when you're in the cloud. You have the idea of co-tenancy. Your data and your applications may be running on the same physical infrastructure as other tenants. Your data may move across geo-boundaries and across physical locations. Being able to have security that can give you the ability to apply policies and apply controls no matter where your data resides. And that's why when moving to the cloud, you need to do it in that fashion, to think about the security as it leaves the confines of your data center and extends out to the cloud. And really in a hybrid environment, things go back and forth. You want to maintain that same security posture that you'd have inside your data center through the cloud infrastructure and services that you're taking advantage of. What hardware brings to the table is the ability to verify the security of the infrastructure you're running on, and then use that verification, use those security primitives of secure boot and encryption and attestation to then apply policies to your data and policies to your applications as they're running in the cloud. And that's really the hook point that I'm talking about of why hardware does matter even in the abstracted cloud. So
let's back up just a second. And what is it that, if I'm moving to the cloud, this idea that my workload is moving around, what's causing that to happen, that I'm moving to different geolocations and different places? Why isn't it staying in one place in my cloud?
So you make a really good point there, Todd, about what's the advantage of the cloud. And the advantage of the cloud is around elasticity and the ability to provide the best performance for your applications and for be able to service the different areas where your applications are needed. It also has a key factor of it is the cost of being able to get the most capacity for the least cost and to be able to scale that. To meet that needs, behind the scenes, the infrastructure is dynamic. The infrastructure is, as the term they use, elastic and can spin up and down and across different systems to meet the demand that your workloads, the data, and the consumers of those applications need. And so when you provision your applications, your data, and your workload to the cloud and open it up for your business partners, your customers, and your employees to access it, the cloud infrastructure is going to dynamically provision capabilities to meet the need and meet the demand based on the constraints you apply. Oftentimes, it's about performance and availability around the clock. To meet those needs, the cloud infrastructure will migrate and provision the resources, the hardware infrastructure, the services, and the software infrastructure to support your application as needed to meet those SLAs. That may include spinning up new workloads and new instances across a given cloud region, or taking advantage of multiple cloud regions in order to be able to service the different communities. If you have an application that has to be able to service folks across the world, so in Europe or Asia, as the sun moves, you're going to have infrastructure that spins up in those environments to give you the best performance and best availability for those different markets. Now, that's all well and good from an SLA perspective, but then when you look at sort of the regulatory requirements about data retention and data privacy and data protection for that data, as it traverses those boundaries, the regulations change, and where you're being governed can change. And so you want to take into account what data can move and what data can't, and apply policies and controls to that infrastructure that's rooted in hardware to be able to enforce those requirements to make sure that you aren't violating various compliance regimes and compliance requirements for protecting the data as it transitions across the cloud. We're not saying don't use the cloud for all that it's good for, but the key is to make sure your policies and security controls match the cloud capabilities so that you can maintain compliance and maintain your security posture.
The article this podcast is based upon can be viewed in the best-selling cybersecurity leadership book, CISO Compass, Navigating Cybersecurity Leadership Challenges with Insights from Pioneers, available at Amazon.com and other booksellers. So I know, working for one large organization, we were building a global application, and ran into a couple of roadblocks with some of the countries, such as Germany, that the data couldn't leave Germany, or France or Sweden had more restrictive controls. Not that they're the only ones, but just as an example of those. How do you deal with that, where a country doesn't want their data to leave, but you're trying to build a global application at the same time?
So there are multiple ways to tackle that problem. Oftentimes you look at, well, what type of contractual controls can you put in place, or do I have to replicate my infrastructure across all those different geos? And what you find in the early days of the cloud adoption, when they start to come up against those sovereignty issues, is that companies would then stand up infrastructure in each of those countries. And number one, that didn't scale. It was very costly. And then you end up with silos of capability that weren't connected with each other. A better approach is to be able to build your applications independent of the data, and so that your applications can move where they need to be from a performance perspective, but the data that they operate on can be maintained in the geolocation. Or when German customers, for instance, need to access an application, it's married up to the data sets that's located in Germany and stays there. And there's the key problem. How do you enforce that the data and the application that's processing that data is in the geo boundaries necessary? So this was part of the overall problem set that back in 2015, NIST took a stab at looking at how can we do trusted geolocation in the cloud? How can we get better attestation to the physical infrastructure using that physical asset as the hook point to be able to determine where your data is and enforce that policy? And so working with a collaborative team of industry providers, software, hardware, and ecosystem and cloud providers, they developed a reference architecture that they published as the Interagency Report 7904 for trusted geolocation in the cloud. And really what it defines is a mechanism of leveraging hardware root of trust, so that's the ability to verify the hardware and the software, the firmware, and the operating systems and virtualization stacks that are running on top of it, along with additional attributes like geolocation or policy tags, and have that bound together into what we call an attestation event. And then have that hooked into the orchestration systems. And that's the key thing, hooking the hardware and the policies that you have there into the orchestration, so that when a provisioning event needs to occur, the orchestrator at the cloud scale will leverage those policies and say, I have a workload here that needs to work, that's for German, let's say German citizens. I can attest to the hardware platform that it is located in Germany and that it's associated with this policy regime. And then the orchestrator can migrate and provision resources accordingly. So it's not like you want to be able to create some manual process, because that itself doesn't scale. But by tying the hardware attestation into the orchestrator, into the scale and provisioning systems that the cloud providers use, it allows them to be able to operate at scale, but then leverage those hardware policies. And so what NIST did is created a reference architecture. It built it for both commercial software packages like VMware, as well as open source, OpenStack-based approaches, and demonstrated it with a hybrid cloud and documented, here's how you build a reference architecture for doing geolocation in the cloud. They followed on with multiple further follow-on publications about how do you configure the systems, how do you configure the operating environment, and how do you extend that to data security and other use cases. But the idea is that you want to build a system or leverage an infrastructure that supports the attestation of those security requirements and security attributes, and embeds that into the orchestration and scale provisioning system, so that your policy rides with your applications. And really what it does is it marries security requirements with your SLA requirements in a single instance. And that way, as you're provisioning resources to meet the SLAs of the German use case that we talked about, your security controls are along for the ride or are being enforced in real time. And that, I think, is the key connection that the NIST reference architecture highlighted. Is it's not we're trying to break the way the cloud works. We're giving the cloud these ability to provision with security policy married to it.
I really like that idea. And so how far along are we in implementation of getting this reference architecture into products that people can buy and use today?
That's a really good question, Todd. And the answer isn't a simple one. The underlying technology itself, so the hardware features have actually been in servers for many years. The actual hardware features we take advantage of have been in the server infrastructure since actually 2012. And so any server that's been deployed in the last 10 years has the nascent capability. The infrastructure stack, so the hypervisors like VMware and Zen and Red Hat and others have all taken advantage of this capability and have those features available. The orchestrators, whether it be things like HighTrust or OpenStack and OpenShift and others, have the ability and have the features added to support this. So the underlying infrastructure has been built in collaboration with NIST to be able to deploy this capability. And we've seen cloud providers take advantage of this both for the public cloud as well as for hybrid and private on-prem implementations as well. To give an example, IBM's Trusted Cloud leverages these capabilities and allows you to make those provisioning determinations as part of your policy for scaling and implementing your performance requirements. So it's built right in as a feature. You sort of select it on, and then you can apply those policies, both geolocation as well as security controls, on your public and hybrid clouds. Similarly, we've seen some of the hosting providers that are leveraging VMware infrastructure or Red Hat OpenShift and OpenStack infrastructures deploy these capabilities for their hybrid cloud implementation. So we are seeing customers, service providers provide these capabilities, and we're seeing customers deploy it for their hybrid infrastructures. And we're seeing this more, this adoption just become more and more. When you talk about some of the large hyperscaler clouds, a lot of times these technologies are what they use internally to help protect their tenants, but don't necessarily give their tenants direct access to those features because they're offloading even the security controls of the infrastructure as part of the service package. But a lot of those cloud providers are leveraging these technologies because, again, you want to verify the infrastructure you're running on and provide good security controls on where data and applications can move to.
I think this sounds great and addresses a real issue with the data moving around, and how do we make sure that we're complying with all the different laws and regulations. You have seen the cloud transformation that's been occurring over many years now. What would you say to people that are still apprehensive about moving into the cloud?
I would say that the cloud is here, and it is a key factor of how we deliver our services and our capabilities to our customers, and that crosses every vertical and every sector. The important thing is that if you're just now starting to look at how you move to the cloud or you're late to the game, you can take advantage of all the work that's been gone before. And so there's no need to make the mistakes of everyone who jumped headfirst into cloud in their early days. Learn from what they've done and take advantage of the best practices that are out there. Building security and security policy in from the get-go, designing it into your migration to the cloud, understanding that you need to have a security policy that can go from hybrid, so on-prem to the cloud, as well as a multi-cloud approach to how you're securing your data and applications is much easier to do when you start than trying to bolt it in after and when you're already out there in the cloud. It's very hard to pull it back in. And so one of the best practices we've seen for folks that are, think about them as the late adopters, is for them to build and design security requirements, security controls into their initial provisioning into the cloud, because it will make that they can leverage all of that pre-work that the industry and the marketplaces have already done. The other thing is that many of these capabilities are available. You just have to turn them on. And I think that's been one of the key lessons learned, is whether it be hardware security features or cloud service provider security options, whether it be virtual security appliances that you deploy with your app cloud infrastructure or nascent features that are already there. Turn them on and take advantage of them. Don't wait until after you've already deployed to go back and look and see what you could have done to secure your cloud.
Are there any good resources that you find that you particularly like around moving to the cloud?
So there's a lot of good content out there around how to securely adopt the cloud. I think if you're just starting out, some of the best resources is the cloud providers themselves. Going to AWS or Azure or Google Cloud and reading their security documents. And understanding how the cloud providers are providing best practices from both themselves as well as from their tenants and their marketplace is a good place to start. From there, looking at Cloud Security Alliance and SafeCode have best practices and guidance that are very helpful for organizations looking at across different cloud architectures and cloud instances. And then finally, of course, NIST has really great documentation on the reference architectures necessary for adopting cloud at scale, leveraging what the public sector and the federal government has done to adopt cloud. Looking at the content that CSA and SafeCode and NIST have put out, and as well as the other regulated industries, public sector, government has put out really good documentation on how to secure your cloud infrastructure, best practices, and even for regulated industries like financial services and critical infrastructure, those industry organizations have really good content. So my recommendation is to start with the cloud providers, the ones that you're already investigating or working with, and read their content on how to secure their cloud infrastructure. And then go to folks like CSA, the Cloud Security Alliance, and SafeCode to look at best practices across cloud architectures and cloud service providers.
Well, Steve, this has been great. Is there anything else that you'd like to leave our listeners with about moving to the cloud and being successful in the cloud?
So Todd, I think one key takeaway is as much as the cloud providers and the cloud industry want you to believe that all you have to do is go to the cloud and you will be good enough and secure enough, infrastructure matters. It matters inside your data center, it matters in the cloud, and especially matters in a hybrid multi-cloud environment. And what that means is taking a close look at how you're securing your applications and workloads and data as they traverse these different cloud architectures, service providers, and service models. And to that end, recognizing that hardware and the infrastructure have the capabilities to provide that enhanced security that you're looking for if you take advantage of it.
Well, Steve, this has been great. And thanks for taking the time to share your knowledge with the CISO Compass book and to go into some depth in this interview. Thank you very much for taking the time.
Todd, it's been a pleasure. Thank you so much.
Thank you.
Cybereason is the champion for today's defenders, providing an endpoint security platform to prevent, detect, and respond to malicious operations on computers, mobile devices, servers, and the cloud. Cybereason. End cyber attacks from endpoints to the enterprise to everywhere. Learn more at cybereason.com/CISO stories.